find the domain of this guy. So basic idea of domain stuff is we need the square root of star to guarantee that star is greater than or equal to 0. And we need, in the event that we are dividing by star, and we have anything over star, that's going to need to guarantee us that star is not 0. Then, once we've solved those two, we have to say that both are satisfied. Okay. In this example.
Yes. So we know that 3x plus 7 has to be greater than or equal to 0. And in the denominator, we know that, yeah.
Be careful you don't leave it.
Yeah, like I know.
Right. Okay, and then the denominator.
Yeah, so it's going to be, you can factor that to x minus 11.
So this is,
x plus
4. This is actually what x is not.
Exactly.
Yeah. So, in other words, so
x cannot be negative or positive 11.
I should make it look not like the absolute value of 2.
Okay.
Right. X minus 11, x plus 11, x is not
11 or negative 11.
Okay. So let's look at a number line here.
Yes.
We know that we have to exclude negative 11. We have to draw a colored in dot at negative 7 over 3 and say, okay, we're good to the right of that.
Yes.
But then we have to exclude
11. And so if you test, now it's time to test the regions.
There is no no, this is just domain. We're done now. We're not solving an inequality, right?
Okay.
Testing the regions is where we solve an inequality.
Okay.
We're essentially done in that our domain is, I'm going to do it in red. We have a closed bracket here, an open bracket there, an open bracket there,
and then
negative or positive. What am I? Okay. The thing about this bothness here is that we don't care about this requirement anymore. It's automatic.
Yeah, because that's
right.
Before the negative.
So in the end, if I wanted to present my answer to the court, I would say negative 7/3, comma 11, union
11, comma infinity.
Okay. And
that's the end.
Yeah, that's essentially it. Couple of things to probably be careful of, which are, oops. I'm just going to start a new page. Okay, I deleted some things at the end there. That was unfortunate. A couple things to be careful of is that, let's say I'm doing something like 1 over the square root of x squared minus 4.
Mm-hmm.
You could say to yourself, oh, x squared minus 4 has to be greater than or equal to 0. But there's a secondary restriction that says it also has to be not 0.
Yes. So in this case, would you say that it was just greater then?
That's an easy way to deal with it.
Yeah.
Here, you mentioned testing the regions before. Now I'm solving a complicated inequality.
Yeah.
So for this type of example, I would go through my inequality steps, meaning now I set it equal to 0, x minus 2, x plus 2 equals 0, which tells me x is either 2 or negative 2. Now I draw my region. I draw my number line. Remember, this entire thing that we're doing here is a sub-problem. As it turns out, in evaluating the domain of this expression, it required that I solve this complicated inequality.
Yeah.
Complicated meaning not linear. I can't just move something to the other side and divide. So now I've got -2, and I've got 2, and it's pretty easy to say that this is bad and these are good.
And you're done. I mean, if you had to...
Okay, so now we know that we're looking at -2 to -infinity.
Union 2 to infinity.
Okay, but just because you mentioned testing the regions, and I said, no, you don't test the regions in this type of problem, that's not, a statement to always follow.
It's not written in stone.
Right, because you test the regions anytime you need to solve an inequality that doesn't look simple, like a simple inequality would be x plus 3 is positive. I can just say x is -3.
Yes.
Well, bigger than -3. This is simple. Anything involving factoring or numerators and denominators requires that you test. Okay?
Yep.